Section 9.1. This is basically the language of what we call the hypothesis testing, or the nature of the hypothesis testing. We will introduce here the hypotheses, how do we set them up, and what they are used for. So to do so, first we define what a hypothesis is. Hypothesis, we can say it's a statement or claim that something is really true. Okay, and maybe the definition is vague for now, but you will see what that means in a minute. What we're going to be doing here, we run in general like hypothesis testing, which involves or includes two different hypotheses. One is called the null hypothesis and one is called the alternative hypothesis. What is the null hypothesis? The null hypothesis is a hypothesis that is going to be tested, and at the end we are going to see if we need to reject this null hypothesis or decide on what to do with it. We use the symbol h sub 0 to represent the null hypothesis. H node here is called, or I just call say h sub 0. This is for the null hypothesis. And then we have the alternative hypothesis is considered as alternative to the null hypothesis. That's what we call the alternative hypothesis. So we will see what happened or how we use them. What are these used for? For the meantime, we're gonna have it in this section that the hypothesis test will be concerning about the population mean. Okay, so it's gonna be a population mean. If you remember, it's mu. It's about this, and this carries a specific value for this parameter mean. So we're gonna see how to express the null and alternative hypotheses. So for the first setup, if you have the alternative hypothesis, would be the mean equals some value, call it mu sub 0. So always the parameter that you have, if it's a mean or anything, but I'm just doing the population mean for now, is going to equal some value. That value will be given to us. So that value will be given to us, and we will see how to set it up number wise. But for the meantime, the mu or the population mean is going to equal to mu sub 0, and the alternative hypothesis, some people use h sub 1. We use either one is fine. In this case, the first case is if the mean is not mu 0, the population mean does not equal that mu sub 0. So this is saying that the population mean is different from that specific value that I was talking about. And this is how we express the setup for the hypothesis testing. So this is the first case. This is called, this is the first case when they are different. The two cases are different. The next one is H0HA. The way this works, always the mean equals mu sub 0, always, regardless. So there will be in all three cases I'm going to show you is going to be the same. For this one, that's when it's going to be less than. And the last case when it's bigger than. So H0 mu equals mu sub 0, and H1 the population mean is bigger than. So in each case, these cases are meant for something. This is called, we call it two-tailed test. Two-tailed test. This one, since it's less to the left, it's left tail test. Bigger than means to the right tail test. Right tail test. Some people call the last two cases one tail test, so that's fine. You want to call them this way or not. What can be an example we would like to test or set up something about? There's so many examples that we can go over and see how to form the hypotheses. And really the forming the hypothesis is the easiest thing that students can find in this section. We can be given a list of incidents or events, and then we need to try to set up or form the hypotheses. For example, I can probably read an example on this. and then we will set it up together. So let's see what we have. The book focuses on the snack company, and let's talk about, let's say, M&M. They tell you, the bag size, weight, sorry, it's 454 grams. Okay, and we would like to know, we need to decide if the mean weight of the bag or all bags of M&M packaged by that company, they differ from the one that they advertise or not. So they advertise that the weight for each bag is 454 grams. They advertise it this way, but we would like to test this claim. Is this really right? Is it always true this way? So what we need to do is we need to find the null and alternative hypotheses for this. We need to see if the weight that they advertise for is different. Is the weight different than, like, if you pick, let's say, like 20 bags of M&M and you weight them, will they be the same as this one that they advertise? So always for the alternative hypotheses, the mean is going to be the 454 grams, and alternative hypothesis is the mean weight for the bags will be different than the one they advertise or not. So now you can tell this is a two-tailed test, right? So the word different tells you that this is going to be different here. Another example. So let's say a company or like just a company that developed a new medication for students, antibiotic medication for children. And among the competing antibiotics, they found 2% of the children who take the drug experience headaches as a side effect. So 2%. A researcher for the Food and Drug Administration wishes to test the claim that the 2% of children taking the new antibiotic who experience headaches as side effect is more than 2%. So H0 in this case, they're talking then, here they talk about the population proportion. But if we switch it to a mean somehow, like the mean weight of something, the mean weight is 2%. So 2% means 0.02. And for alternative hypothesis, they said it's going to be the side effect more than 2%. So more means the right tail test. As you can see, it's a right tail test. We can look at different example, but they are all really easy and straightforward. They will tell you in all the problems, if it's more than, less than, or greater than. So then you know which one is it. Is it right tail test, left tail test, or is it two tail test? So when they say different, not the same, it means two tail test. It means two tail test. And what is the logic behind the hypothesis testing? The logic behind it, you first decide on the null hypothesis and the alternative hypothesis. And at the end, you're going to do some work, and then you need to decide at the end, do we reject the null hypothesis or not? Do we reject the fact that the mean weight of the M&M bags is 454 grams? Do we have to really reject that or not? And the procedure to do this, usually people select a random sample. Like in this case, we pick like random sample bags of M&M. And if the sample data consists with the null hypothesis that all the weights are really like the same or almost the same, 454 grams, then we do not reject the null hypothesis. We just say, we support this claim or the H0, and we are done with it. But if the data is not consistent with this, like you weighted sometimes more on, or if, especially if you find the majority is less, that would be not a good thing. With the null, so the numbers you get are not consistent with the null hypothesis, and then in this case we need to reject the null hypothesis. Okay, we reject. Okay, we say reject. Now, one thing I want to point out, in the statistics language, we do not say we accept the null hypothesis. We do not say, we just say we do not reject. I know it could mean the same in English, but in statistics it's different. So you must say we do not reject the null hypothesis. Means we support it. We support that thing. Sometimes if we reject the null hypothesis, this means we are supporting the claim for the alternative hypothesis. Then the mean weight for the bags for M&M are not always as they advertise it as 454 grams. That's the logic behind this one. Now, sometimes some researchers, let's say, or someone who's not careful about what to select for the data, they select like a small sample, like really small sample. Maybe they selected only 2 bags of M&M instead of selecting 100 bags. And then they try to say, oh, these 2 bags are not 454 grams in weight. So then they try to, make a decision or conclusion about the entire population. So sometimes researchers make mistakes, or we call them errors. So what happened in this case if they make errors? Well, the conclusion will be different than what is supposed to be in fact, in reality. So if someone rejects, or a researcher rejects the null hypothesis, when it is, in fact, is true, it's true, but they say, oh, we reject the null hypothesis, they made a type 1 error. They made a type 1 error. And at the same time, another mistake or error they can make is not rejecting the null hypothesis when it's, in fact, is not true, it's false. So that's called type 2 error. So it's all about rejecting, but in fact it's not supposed to, or not rejecting, but in fact they're supposed to. So these are the 2 things that are important here to know. And let's look at an example before we go through this stuff. Let's say, again, we go back to the M&M packaging hypothesis. So we said the null hypothesis, the mean is 454 grams, and the alternative hypothesis, the mean was different. Okay, and what happens here? Why would there be a difference in the weight in the bags? This could occur because of the machine that is being used to pack those M&M stuff. So what happened here? So the first one, it tells us that the machines being used is working properly. The machine, I'm gonna say, is fine. The machine is not fine. Okay, where again the mean is the mean net weight of all the bags of M&M. Now let's say we are going to explain what does it mean to make a type 1 error. What does it mean to make type 1 error? So we make a type 1 error. If you remember, what is type 1 error? Going back, type 1 error is you reject the null hypothesis when it is true. So you reject the, how do we say it here specifically to this example? You reject the null hypothesis when in fact it's true. So to write that down, you will say that we reject the null hypothesis that the mean weight is 454 grams, and we conclude that the mean weight is not 454 grams. Okay, so that's for for the first one. Okay, so type 1 error again is that you reject the null hypothesis, but in fact you're not supposed, it's true, you're not supposed to reject the null hypothesis. Now, what about type 2 error? Type 2 error. So for this specific one, so type 2 error, it occurs usually, it occurs when we are not rejecting, so this is not rejecting the null hypothesis when in fact it is false. So this means you know it's the alternative hypothesis correct, that the mean weight is not 454, but you still you will have, or you will come across that type 2 error when you say that when you support the claim about H0, you support the claim. You say that that the mean weight is 454 grams. That's really the mean weight for the M&Ms. But in fact, this is a false thing, false result, and you should be rejecting it and not let it go this way. So that means it's a type 2 error. In this case, the type 2 error occurs here. Again, if we fail to conclude that the M&M machine is not working properly, when in fact it's not working properly. Okay, when it's not working properly. So that's what type 1, type 2 errors that they have here in this section. Now we have what we call probability. What is the probability of making a type 1 error? Because what happens here when we run the hypothesis testing, we need to see how effective this test is about making at the end a decision to reject the null hypothesis or not to reject or fail to reject it. So if we go through type 1 error, the probability of making type 1 error is called the significance level alpha of a hypothesis test. It's called significance level. This is just the probability of making type 1 errors, called the significance level alpha. That's for type 1. For type 2, so the probability of making type 2 error is called beta. It's called beta. So the relation between alpha and beta is that if alpha increases, beta decreases, and vice versa. So here it says for a fixed sample size, the smaller the alpha, the larger the beta. It makes sense. If you're talking about two things, if you increase the probability of something to fail, you are reducing the probability for the other one, and vice versa. That's what they're saying. Just keep this in mind, because we will come back and use alpha a lot, but not in this section. Just an idea about this. Just keep it in mind. It's called significance level alpha. Significance level alpha.